Hi everyone, welcome back with another question. I'm back with another question. The question says this: find the peak element in a mountain array. Okay, so it says that we need to find the peak element in the mountain array. So first see what is a mountain array. Okay, you know, let's take an example of a mountain. What is a mountain? It starts gradually. Okay, it starts gradually and then it decreases. Okay, that means in the mountain area also we have elements which start to increase gradually. 3, it reaches a peak. It reaches a peak element and then again it decreases. It comes in back in the decreasing order. It is not mandatory that it should be equal to the other elements or not equal to the other element. It may be that the increasing elements are not equal to the decreasing element, or it can also happen that the increasing elements and the decreasing elements may match few elements. For example, 4, 3, 2, 0. So here 2, 3 and 0 are present in the decreasing array also, but but this is a whole itself is a array. This whole itself is a part of the array. So the array represents something like this: 0, 1, 2, 3, then 5, then 4, 3, 2, again 0. Okay, now see, we have multiple elements occurring, but we have these two parts of the array. First part is the increasing part, this part, and the second part is the decreasing part. Okay, first part is our increasing part, second part is our decreasing part. This is called an mountain array, a mountain array. Now it says find the peak element in mountain array. Okay, an array is mountain. The mountain array holds these properties, these properties. Okay, and in that we have to find the index such that the peak index. Okay, the peak index, the index which holds the peak element, this one. Okay, so which index is this? 0, 1, 2, 3, 4, 5, 6, 7, 8. Which one is the peak element? 4. Peak index 4, because it holds the peak element. Okay, so we will return 4. 4 is our index value which holds the peak element 5. Now it has already said that you must solve in big O of log array dot length means big O of log and time complexity. Big O of log and time complexity. Now it has already said that. So one thing clicks our mind that in searching, first of all, this question is of searching. By the question, we should be able to know that we have to search an element. We have to search an element, or we have to search a index. So this question comes to be a part of searching type of question. But which searching takes big O of log and times? Big O of log and times. Which searching takes big O of log and time? Obviously binary search. Binary search. Now now if it was not given, what should we do? We should first approach in our brute force way. Okay, brute force. I will discuss both the ways. And both the code of brute force and obviously our binary search. That is our optimal way. So brute force is quite easy. Let's take a small array. 1, 4, 5, 0. Again we can take like 1 then 0. Yeah. Okay, now see, here it is increasing, here it is decreasing, but in brute force it doesn't matter. In brute force, because we need to find in big O of log and times. Brute force, that is linear search. Obviously linear search, it will take big O of log and time, and it doesn't matter if it is sorted, unsorted, mountain array, whatever, it doesn't matter at all. So in brute force way we will not see it is a mountain array or not. We just traverse an element here, and we will maintain a max element. Traverse the index. We traverse the index 1, 2, 3, 4, and we maintain a max element starting to be minimum value, integer dot minimum value. Okay. Now let's check. array of I that is 1 is greater than max, obviously. So we will update our max to be 1. Now again we will check for the next element. Array of 1 is greater than 1. Yeah, 4 is greater than 1. And update the max. Now see. Sorry. I'm sorry. We will also maintain. We will also maintain a max index starting to be 0. Initially max index is 0. Now when I is equals to 0, max was equals to 1, so we will update max index with 1, that is I. Now when max goes to index number 1, so we will check, is 4 greater than 1? Yeah, so we will update our max element with 4 and max index with I. What is the value of I? 1. So now we will update it with 1. Now for next element, that is index number 2, which contains 5, we will check, is 5 greater than 4? Obviously 5 is greater than 4. Update max element with 5 and update this one also. Update this one with I value is 2. Now go for next element. I is equals to 3. Is index of 3, array of 3 is greater than 5? No, 1 is not greater than 5. Do not change anything, do not change. Now go to index 4. Now check, is 0 greater than this max element? No, do not change these things. Now our loop is terminated. Return this max index, because the question says return the value of I. So we will return our max index, that is equals to 2. Our answer would be 2. So this is our brute force approach, and now we will solve it using the brute force approach. Okay, let's clear this. What we have? We have our max index and max element. Now we have int max I is equals to 0 initially, and int max is equals to dot min value, integer, minimum value of integer. Okay, now we will run a for loop till array dot length. For I equals to 0, I less than length I plus plus. Yeah. Now see, if just use the ternary operator, max equals 2. Now see, array of I is greater than max. If it is greater than max, then update our max with array of I, else it would be max itself. Okay, now update. Now how will we check? Is this max is greater than the previous max? The previous max is not is updated here. Okay, so we do not have any track of this previous max. Okay, so we will have a boolean flag. Okay, let's use if condition. If max is less than array of I, then if max is greater than smaller than array of I, that means this element is greater than max. Okay, so we will update our boolean to be true. Flag equals to true and max equals to array of I. We will update our max. Now we will update our this one, max I. Okay, max I. If flag means if the value of max is changed with the current value of array, so we will update our max I with equals to I, and now change the flag to be false. For the next step, change our flag to be false for the next. At last, return max I. See, not a statement. GHT, sorry, GTH, and I equals to 0, I less than error to n. Yeah, that was the error, I guess. Again, print. Okay, I'm so sorry. If flag, variable flag must not have been initialized. So not initialized equals to false. See, all the test case passed. Also we can run. Yeah, it gives the answer, but see, runtime 2 milliseconds. We need more optimal time. So we will make use of this login time. Make use of login time, that is optimal way by using binary search technique. Okay, now see, we have this array 14510. We have this array 14510. 14510. Now in binary search, what we have? We have three pointers: start, end, and mid. Okay, 0, 1, 2, 3, 4. Now, first of all, initially start will be equals to 0, means 0th index, and end will point to 4th index. Now check middle. What will the middle? Middle will be 4 by 2. 4 by 2, that is equals to 2. And now we will check its previous element is smaller than this, and its next element is smaller than this. Okay, what does that say in mountain array? The previous element of this peak element should be smaller than the peak element, and the next element of this peak element would also be smaller than the peak element. Yeah, so here we will use the if condition. If array of mid is greater than its previous element, that means array of mid minus 1, and we will check for the next element also. Array of mid is greater than array of mid plus 1. If it is true, we will return mid. If it is not true, we will go for the next condition. But here we directly get our answer. Okay, so we will see for another example. We will see for next example. 1, 5, 2, 1, 9. Okay, we have our peak element here. 1, 9, 1, 9, 1, 9, 8, 7, 5, 2, 1, 0. Okay, now see, 0, 1, 2, 3, 4, 5, 6, and then 7. Okay, now start is pointing to 0, end is pointing to 7. Now what is middle? Middle is equals to 7 by 2, that is 3. Middle is equals to 3. Middle points here. Now we will check this first condition. Array of mid, that is 7, is greater than mid minus 1. Mid minus 1, no. 7 is less than 8. 7 is less than 8. So at first only this condition is equals to false, gives false. So we will check for the next condition. In next condition we will check does our middle element is present in the decreasing array or it is present in the increasing array. What does this mean? It means that does This is our increasing array, and this is our decreasing array. Okay, and this is our answer. So the left side is our increasing side of the array, and the right side is our decreasing side of the array. That means if we are in the right hand side, we have to check in this part of the array. Okay, in this part of the array, because we cannot go further more right hand side. Okay, and if we are in the left hand side, we will check in this part of the array. Okay, that means if we are somewhere in middle, we cannot go further back, but we can go further to the right hand side. Okay, so if we are in the left hand side of the array, we will update our start element, and if we are in the right hand side of the array, we will update our end element. Okay, what does that mean? It means if we are somewhere here, that means our middle points this, and our end is here, and our start is somewhere here. Okay, but our middle element is in the decreasing side of the array, so we cannot, we have to go to the left hand side. We will go in the left hand side, for going left hand side, we have to squeeze our array. Like our array is here, our middle element is the decreasing side, so we have to squeeze our array so that we search in this part of the array. We search in this part of the array. We have to ignore this part. For that, we will update our end element to middle minus 1. Now end will come before middle. Now again we will search in this part of the array, in this left hand side part of the array. And similarly, for if the array is if the middle element is present here, let me change the color. If the middle element is present here, somewhere here, we cannot go further backward. So we have to check. See, this is the array, middle element is somewhere here, we cannot go further backward. We have to go beyond this. We have to ignore this part. Here we were ignoring this part, here we are ignoring the left hand side of the array. So we have to go here. For that, we will do start is equals to mid plus 1. Start will be updated to here. Now see, now check here. uh, Now see, we have middle element to be the decreasing side of the array. So what we will do, start to be mid minus 1. Start will be updated to be mid minus 1. Okay, now mid start comes here. Now what is our new mid? New mid is equals to 2 by 2, that is 1. New mid is equals to 1. Now check this again. We will call for this condition. Now see, 9 is greater than the previous element. Yeah, 9 is greater than the previous element. Now check for the next element. 9 is greater than 8. Yeah, 9 is greater than the next element also. So this is our answer. 1, return middle. This is our mid, return mid. Okay, now there is a catch. I will discuss it while coding. Okay, we have to mention one more thing in our condition, that mid should be greater than 0. Okay, why that? Let's see. Now we will clear our code right now. Optimal way description. See, we have start equals to 0, and we have end equals to array dot length minus 1. Now while start is less than equals to end, we will run the loop. Now we find the mid is equals to start plus end minus start by 2. Okay, now we will check this one. The first condition, if middle element is greater than the previous and the next element, if array of mid is greater than array of mid minus 1 and array of mid is greater than array of mid plus 1 mid plus 1 mid plus 1 sorry mid plus 1. If it is true, return mid. If it is not true, we will check this condition, this if it is on the left hand side of the array or right hand side of the array, that is in the decreasing side of the array or uh, the increasing side. So let's check for any one thing. Let's check for increasing side of the array. If array of mid is greater than, sorry, it would be less than increasing side, yeah, that means the next element would be greater than the mid is less than array of mid plus 1, then simply do start equals to mid plus 1, else the array or the mid element is present in the decreasing side of the array. For that we will do end equals to mid minus 1. Okay, now if everything fails, if all this fails, just return -1, okay. So let's see if it runs or not. It will not run. It will, okay, it is running right now. Let's see if all the test cases are running or not. No, see here what I was saying, that we have to add this condition, mid should be greater than 0. Why? Let's see. Array index of bound, array index -1 is not present. Index starts from 0. Is there any -1? No. Okay, but why -1 exception is coming here? Let's see the input. Input is 35230. Let's check. Let's try run. 35320. 35320. Now it is giving index out of bound, that is -1 is out of bound. Let's see. Start end. Okay, 0 1 2 3 4. Now let's see what is our middle element. Middle element is 4/2, that is 2. Middle element here, index number 2. Now if this element is our peak element, no. Why? It lies in the decreasing part of the array, so update our start to be mid -1. Okay, start comes here, sorry, end. Update our end to be mid -1. End comes here. Now our middle element is equals to 1/2, that is equals to 0. Now middle points to be 0. But what is our condition? If array of middle is greater than array of mid -1. Okay, so we will check this one. Array of mid is greater than mid -1. What is mid -1? -1 exists? No. So here we get our array index out of bound, because there is no -1, but we are checking for it. Okay, so we will add this one. Mid should be greater than 0. Okay, so this condition does not satisfy. This mid is not greater than 0. Mid is equals to 0. So mid is 0. Where does mid lie? Mid lie in the ascending side, that is increasing side of the array. So this condition will match. So we will do start equals to mid plus 1. Start will come here. Now both start and end point to this one element, one index. Now mid will be equals to 1, because both element points here. Mid will be also here. Let's check. 1 plus 1 minus 1/2. It is 1. Okay, this gives 0, but this 1 is here, so it gives 1. So our mid element is equals to 1, and 5 is greater than the previous element and 5 is greater than the next element. So this condition satisfies this condition. In the next iteration it will satisfy this condition. Now let's run, submit this. Yeah, it's running perfectly fine. See, beats 100% of the user of Java. Okay, so that's all. Do remember why we are using mid is greater than 0, and that's all. Thanks for watching.